Hello guys. So sorry. So after we have studied about the introduction to thermodynamics, we have also gone through the advantages and disadvantages of thermodynamics. Now our purview will be learning some of the important terms in thermodynamics that we are going to use in the chapter time and time again. Those names will be used and you need to understand the various significances associated with those names. Okay. So first of all, when we are talking about thermodynamic study, the main thing that we have to understand is that we are talking about macroscopic view. We are talking about bulk quantity. We are not talking about atoms, individual atoms or individual molecules in that matter. Okay, so when we are studying a subject, then suppose I am having this container, okay, this is an irregular container as you can see, and there is some water which is boiling over here. So it is boiling, some vapor is going out. So if you see, there is a irregular container over here in which the water is boiling. So what I am going to study over here, I am studying the water boiling inside the beaker. Okay, I am studying the water boiling inside the beaker. So basically the part of the total universe which I am studying at this moment is called system. Okay, part of total universe under thermodynamic investigation. Okay, so the part of total universe that is under thermodynamic investigation will be called system. So this part is under thermodynamical investigation at this moment. So this is the system. Okay, now the remaining part of the universe around the system, so all the other parts except the system, okay, so all other parts except the system is called surroundings. Okay, all other parts except the system with which the system is interacting. Okay, there is some interaction, some heat may be coming through here and the water is boiling, some vapor is going out to the surroundings. What do we say? Vapor is going to the surroundings. So anything other than the system will be called as surroundings. So this is the system. बाकी कुछ भी है तो है surroundings. Okay, and the system and surroundings is separated by something called boundary. This is very important. Okay, something called boundary. Okay, so here we can see one part is called system, the other part, whatever is there in the total universe except that part of thermodynamical study is called surroundings. So I can easily write system plus surroundings is equal to universe, right? So total universe will contain the part that I am talking or I am investigating, that is the system, and anything except that system is called surroundings. So system plus surroundings will be universe. Okay. Now this system and surroundings is separated by something called boundary. Okay. So there are different kinds of boundary that we are going to study. Okay. So boundary can be a rigid wall. Okay. Rigid wall means basically its position is fixed. Okay, nothing else. Rigid wall means the walls of the room is rigid wall. Okay. It may be an impermeable wall. Now this rigid wall may be impermeable wall. It may be an impermeable wall. What does an impermeable wall necessarily means? An impermeable wall doesn't allow any matter to pass through. It doesn't allow, here the position is fixed, doesn't allow passage of matter. Okay, impermeable wall doesn't allow passage of matter. Okay. What is a permeable wall? It allows passage of matter and energy. Okay. Permeable wall will allow passage of matter and energy. Impermeable wall will not allow passage of matter. But that doesn't mean that it will not allow passage of energy. The next type of wall we will be talking about is diathermal wall. Okay. The next type of wall we will be talking about is diathermal wall or diathermic wall. Listen, if there is thermal word is there, as we have already spoken about, thermo means energy. So diathermal wall or diathermic wall will allow passage of energy. Okay, diathermal wall will allow passage of energy. But it will not allow passage of matter. Okay. But it will not allow passage of matter. It will allow the passage of energy. Energy को पास करने देगा, but matter को पास करने नहीं देगा. फिर से एक बार दोहराते हैं. Rigid wall, the position will be fixed. Impermeable wall means it will not allow passage of matter, but it will allow passage of energy. Permeable wall सब कुछ allow करेगा. तो पहले हम लोग permeable को रखते हैं. Permeable wall will allow matter and energy to pass through. Impermeable wall, that means the walls of your house, it doesn't allow passage of matter. Okay, हाथ घुसा नहीं सकते हो आप wall के अंदर से. But when there is very cold outside, you will also feel cold because it is allowing the energy of inside the room, heat energy, to go out. So that is the example of impermeable wall. It is not allowing passage of matter through it, but it is allowing the passage of energy through it. ठीक है? अभी एनर्जी को अलाउ करने के लिए डायाथर्मल वॉल भी हम लोग कंसीडर कर सकते हैं. So diathermal wall means it will allow passage of energy. Okay. So permeable wall will allow passage of energy and matter. Impermeable wall will not allow passage of matter. Diathermal wall will not allow passage of matter but will allow passage of energy. Another type of wall is there, that is called adiabatic wall. It will not allow passage of energy. देखो जो एनर्जी को पैसेज अलाउ नहीं करता है वो मैटर को भी नहीं अलाउ करता है. ठीक है. इसमें इंपॉर्टेंट कौन कौन सा है, ये दो चीज बहुत इंपॉर्टेंट है. देखो, इफ इट इज diathermal wall it will allow passage of energy. If it is adiabatic wall it will not allow passage of energy. So if it's, I am having a copper beaker, a beaker made of copper, then this is a diathermal wall. Okay, because it will allow the heat to come in and go out. ठीक है. But when I am having very properly insulated vessel over here, then it may be called as a adiabatic wall. Okay, this wall can be called a adiabatic wall क्योंकि इसमें इंसुलेशन के वजह से हीट बाहर नहीं जाएगी और अंदर आएगी भी नहीं, तो इट कैन बी कॉल्ड एन adiabatic wall. ठीक है, दिस कैन बी कॉल्ड adiabatic. बट प्योरली adiabatic बोल के कुछ नहीं होता है. ठीक है, देयर कैन नॉट बी समथिंग व्हिच इज प्योरली adiabatic. मींस एक जूल भी आपका हीट एनर्जी इधर से उधर नहीं होगा, ऐसा कोई हुआ देयर, बिकॉज देयर इज नो परफेक्ट इंसुलेशन. ठीक है, ओके. सो आई होप यू हैव अंडरस्टूड द वॉल्स दैट वी हैव डिस्कस्ड. नाउ वी आर डिस्कसिंग अबाउट सम सर्टेन सिस्टम्स. सो विल बी आल्सो naming various kind of systems while the purview of our study in detail. So पहले we should understand that what are those names and what are the meaning of those names. So one by one we will go through. Very easy, nothing is hard over here. Until now whatever we have studied, as you can see, still now it is very easy. तो धीरे धीरे करेंगे तो सब easy रहेगा, ऐसा कुछ नहीं कि बहुत टफ कुछ है. ठीक है. So now there are types of systems. So there are various types of systems. I'll just write the names first. Ideal system, real system, then open system, closed system, isolated system. So we'll be discussing these systems one by one so that we get a fair amount of idea that what are the systems that we are going to study, or we are going to get these names time and time again. So you have to understand that what does it really mean. Ideal system means basically there is nothing called ideal system. Okay, ideal system means that is in your खाते पेन पे जो लिखते हो वही आइडियल सिस्टम है. सो पेन एंड पेपर वाला थियोरेटिकल जो सिस्टम होता है दैट इज आइडियल सिस्टम. 100% एफिशिएंट सिस्टम इज एन आइडियल सिस्टम. इट्स लाइक आइडियल मशीन. इट्स लाइक, सो आइडियल मशीन लेके तो बात नहीं करेंगे क्योंकि दिस इज नॉट फिजिक्स, वी आर टॉकिंग अबाउट केमिस्ट्री. सो इट विल बी लाइक ए आइडियल प्रोसेस. सो जिसमें आपका 100% एफिशिएंट रहेगा, कोई एनर्जी लॉस नहीं होगा, बट दैट इज एक्चुअली नॉट पॉसिबल. ठीक है, सो दिस इज बेसिकली थियोरेटिकल काइंड ऑफ सिस्टम विद 100% एफिशिएंसी, which we will call ideal system, but that is actually not there. Number 2 is real system. Real system means in which there is deviation from ideality. Okay, so if there is deviation from ideality, like in the fluids we have seen, PV is not actually is equal to nRT. There is a Z value which shows the deviation from ideality, compressibility factor Z, which is not is equal to 1. That can be more than 1, that can be less than 1, but which is not exactly equal to 1. Okay, so that is the deviation from ideality that we have already studied. So that is why the systems or the processes we are talking about are never ideal. Okay, so they are real systems. So all the systems in this world, in this art, in this universe are real systems and not ideal systems. Okay, next we will be discussing about the open system. Okay, what is open system? Suppose there is a beaker and the water is boiling, so it is open to atmosphere, open to the surrounding. This kind of systems will be called open system. Okay, so can we have an example like I am inhaling and exhaling, so this thing is open to the surrounding, so this is an open system. Okay, so breathing is an open system. Breathing of human being is an open system. Simple है. अच्छा, चलो, what is closed system? Okay, see, if I talk of open system, now there is the water boiling over here and the vapors are going outside. So basically matter and energy is getting exchanged. Okay, closed system में क्या होगा? सपोज यही बॉइलिंग वाटर को हम क्लोज कर दिया, प्रेशर कुकर जैसा कर दिया जिसका सीटी नहीं बजने वाली है. ठीक है, प्रेशर कुकर जैसा कर दिया जिसका सीटी नहीं बजने वाला है, तो इन दैट केस व्हाट विल हैपन इज matter is not going to go outside, but if it is a metal vessel then obviously energy is going to go outside because there will be transfer of heat through by conduction from within this metal. Okay, there will be conduction, there will be transfer of heat. So matter out to hoga nahi, but energy will get exchanged with surroundings. Energy will get exchanged with surroundings. Now, in case of isolated system, there is another modification that we have to do over this one. I am making it closed only, but what I am doing is I am insulating this beaker with a very perfect insulation which is impossible. ठीक है, very perfect insulation तो होता नहीं है कुछ. There is nothing like 100% insulation, but okay, 99% पकड़ लेते हैं. So in this case, obviously there won't be any exchange of matter and there won't be any exchange of energy also, because this insulation will not allow heat to go out or come into the system. So isolated system means no exchange of matter and energy. That is what isolated system is. So these are the systems that will be time and time again coming into your textbooks and your various problems we do. So you have to know what kind of system it is. So in open system, matter and energy both are getting exchanged. In closed system, only energy is getting exchanged. In isolated system, there is no exchange of energy or matter. ठीक है? Okay. एक दो सिस्टम है, we will complete that also, and after that in next session we will be studying about various properties of thermodynamics. Okay. So while we studied or we started thermodynamics as a chapter, then I said thermodynamics will be applicable in case of macroscopic properties. So macroscopic system is a very important term that is going to be used, and you have to understand. Macroscopic system basically means the system is consisting of large number of atoms and molecules. We are not talking about any individual atoms and molecules in case of macroscopic system. Okay? We are talking about large number of atoms and molecules in case of macroscopic system. Okay? So there will be large number of atoms and molecules, large number of atoms, molecules. Okay. So there will be some bulk property which can be said about these systems. So what are those properties that we are associating with those systems? Those are called measurable properties, and those properties are like pressure, temperature, composition, viscosity. Okay, this sort of properties are associated with macroscopic systems. So when there is large number of atoms and molecules are considered, then it is macroscopic system, and which is the purview of our study in case of our new chapter called thermodynamics. It is not no more new. ठीक है, अभी भी नया लग रहा है क्या? It is no more new. बहुत कुछ सीख लिया already हम लोग इसका. Okay, now macroscopic system हो गया आपका. Next is there are another two kinds of system that you need to study. One is homogeneous system, another is heterogeneous system. ठीक है, ये आपको एक्चुअली मालूम है, ये ज्यादा कुछ है नहीं. एक है आपका होमोजेनियस सिस्टम. तो होमोजेनियस सिस्टम में क्या होता है? होमोजेनियस सिस्टम मींस सपोज there is one single phase. Okay, it's a pure liquid or pure solid or pure miscible gas, or this kind of system is two gases are mixed together. Okay, that can be called a homogeneous. Nitrogen, oxygen mixed together in this room is a homogeneous system. Okay, but while I talk about the heterogeneous system, then what is heterogeneous? First of all, heterogeneous can be different phases like solid and liquid, ठीक है, liquid and gas or solid and gas, ठीक है. These are heterogeneous systems, or it may be immiscible liquids, ठीक है. This can be also a heterogeneous system, immiscible liquid, ठीक है. This is heterogeneous. Liquid with gas, like liquid vapor equilibrium, is a heterogeneous system. There is liquid, there is vapor on top of it. That is also a heterogeneous system. Okay. So immiscible liquids means, suppose I have a bottle of oil and a bottle of water and I mix those two inside a beaker, it will not get mixed. So in that case, it's a heterogeneous system. It's not no more a homogeneous system. So when there is marked difference between two phases, which is not mechanically, which is basically you can mechanically separate it, that means it is a heterogeneous system. And if there is complete mixing between two fluids or two solids, in which case mechanically I cannot separate those two things, then it is called homogeneous system. Like mechanically I cannot separate nitrogen from oxygen, right? So it is a homogeneous system, it is not a heterogeneous system. So these systems are very important, so that is why I discussed all this thing with you. After this we will be going through the various properties of thermodynamics, like pressure, temperature. So what kind of properties are they, like pressure, temperature? What kind of property is volume? It may be a different kind of property. Okay? There are certain kind of property which is dependent on the amount of substance. So those are called something, and some properties are there which does not depend on amount of substance, like pressure and temperature. अभी 1 kg वाटर दो या 10 kg वाटर दो, उसको प्रेशर तो सेम रहेगा. स्पेसिफिक हीट कैपेसिटी 1 kg के लिए 10 kg के लिए सेम है, लेकिन हीट कैपेसिटी 10 kg और 1 kg के लिए सेम नहीं है. दिस काइंड ऑफ थिंग्स वी आर गोइंग टू डिस्कस इन आवर नेक्स्ट सेशन. सो अभी देखो, more or less we have covered about the normal introductory part of thermodynamics, about the terms which are going to be used in when we go through the chapter, which is quite a big chapter. तो slowly जाएंगे, उतना जल्दी करने का कोई जरूरत नहीं है. ठीक है. थैंक यू.